Now, let's take something like, say, y is equal to x plus 3. Now, remember last week we spoke about this word functions, and that a function, not all equations are functions. All equations are relations, yes, but they're not all functions. A function means that when you put one input x in there, you will get one input y coming out, and that is a function. So we can see that this is absolutely a function. So because this is a function, we can write it as, can be written as instead of putting y, we could put f of x. F of x, a function of x, is equal to x plus 3, where y is a function in x, right? Now, we know from before that if I had, in a question before, if I had y is equal to x plus 3 and they tell me to substitute x is 1, well, we know that is just to put 1 where x is, right? That is all. So that is 1 plus 3, that is 4, yeah? Or if they say substitute x is negative 3, well, we know it's just to take the negative 3 and put it where x is, right? So now we get y is equal to negative 3 plus 3, which is 0, right? But now that we have this f of x terminology, we could actually write it in a different way. We don't have to write when x equals 1 anymore. Now we could just write the f of 1. So the function when x is 1. So you can see that I put 1 where x is. And that means that in the actual equation here, in the actual function, I have to just simply put 1 where x is. Right? You notice I use the bracketer. Whatever I have in this bracket, I'm gonna put that where x is. And so I put that in a bracket too, showing that that is x. And of course, I would beg you guys to have this habit, right? So 1 plus 3, which is 4. And of course, I could now say f of negative 3, and that just simply means put negative 3 wherever x is. So it's really x plus 3, so I'll put negative 3, that is x, x plus 3, and is equal to 0, right? So, Scotia and Caitlin, do you guys understand what the f of 1 and the f of negative 3 means?
Yes.
All right. No rush, no rush. You can take your time, right? I'll wait. We'll wait for you. It's just the three of us here, so it's all good, right? Now we have a question here, and I'm sorry that it is so scrappily written. Let me just see if I can rewrite it a little better. The f of x, a function in x, is equal to 2x squared plus 3x, right, minus 2. So let me rub off that and write it 2x squared plus 3x minus 2 all over x cubed plus x squared all over 2x cubed plus x squared. So you'll never get a function that is this complicated in CSEC. You should, well, maybe if it's an easy question like this, you have to find the f of 1, the f of 3, and the f of 2. So remember, you're just taking 1 and you're putting it where x is. So I'll do the first one and you guys will do the other 2. Right? So the f of 1 means that I'll take 1 and put it wherever I see x, right? So notice the use of the brackets. I have 2x squared plus 3x minus 2 all over 2x cubed plus x squared. So this will give me 1 squared is 1, 2 is 2, plus 3 minus 2 all over 2 plus 1, which is 3 over 3, which is 1. Right? So f of x, so when x, remember f of x is really y, eh? So we could say here that when x is 1, y or f of x ends up being 1. So therefore f of x, oh no, not the f of x, sorry. The f of 1 equals 1. Nice. So Scotia and Caitlin, you guys understand how to substitute into it and the use of the brackets and all of that?
Yes, sir. Yeah.
Alright, so you see if you could do these two, f of 3 and the f of negative 2, and I'll give you all, how much time you want for that? Take 4 minutes, 2 minutes each. The f of 3, right? So we have the f of 3. I write that f like the Facebook f, and the f of negative 2. Alright, great. Better late than never, sir. Yes, you'll have to look back at the video to see what we've been doing. So take a look at this, Shazay. Shazay, you there?
Yes, sir.
Right. So what we have is we have a function in x, and that is equal to 2x squared plus 3x minus 2 all over 2x cubed plus x squared. Right? A complicated looking function. And we have to find the f of 1. So you can see here that really the f of 1 is me just taking 1 and putting it where x is. So that is exactly what I'm doing in this equation. I'm just taking 1, so you can see here 2x squared plus 3x minus 2. I'm just taking the 1 and putting it wherever x is. And of course, use brackets, please. The brackets will save your life, right? Whenever you're making a substitution, use brackets. Shazay, I have 4 minutes to do the f of 3 and the f of negative 2. And the topic we're doing today is composite functions, right? So 4 minutes, guys. And Shazay, this is what you missed out on over here. How we have a function y is equal to x plus 3, we could write it as f of x is equal to x plus 3, where really f of x is the same as y. Right? So Shazay, take a screenshot of this real quick. Tell me when you're done. Or can you take screenshots?
Done.
Alright, so you can see here we have the f of 1 and the f of negative 3 showing how to make the substitution. And now we have this question here that we were doing. So 4 minutes, guys. F of 3 and the f of negative 2. 4 minutes. And again, all I'm doing is taking 3 and I'm putting it wherever I see x, right? So 2x squared plus 3x minus 2. Notice how the brackets just save, man. The brackets just make everything very, very clear. 2x cubed plus x squared. This just gives me 3 3s are 9, 9 2s are 18, plus 9 minus 2 all over 3 3s and 9 3s are 27. 27 by 2 is 54, and then plus 9. Right? And that will give me 18, sorry, that's 19. 18 plus 9 minus 2 is 25, all over 54 plus 9, 63, and I don't think that could reduce. And let me see, 25 over 63. Yep, that cannot reduce. That's the answer there for f of 3, right? And now let's talk about the f of negative 2, right? So Scotia, Caitlin, Shazay, you guys understand what I did here, right?
Yes,
Yes, sir.
All right. Caitlin, I'm making a note of your absence in answering, but that's okay. Now this is where the kicker is coming in, because we have a negative 2 for x here, and you'll see why that bracket really becomes helpful. So I have 2x squared plus 3x minus 2 divided by 2x cubed plus x squared, right? So what this gives me is negative 2 squared, that is negative 2 times negative 2, 2 2s are 4, positive 4 times 2 is 8, right? Plus, well, I shouldn't be a plus there because this is negative 2 times 3. So 3 2s are 6, but that'll end up being minus 6 minus 2 divided by, now this is the interesting one here. I have negative 2 cubed, and please remember negative 2 cubed is the same as negative 2 times negative 2 times negative 2. So yes, you have negative 2 times negative 2 is positive 4 multiplied by negative 2, you'll get negative 8. 4 2s are 8. So the answer there is negative 8, right? So negative 2 cubed is negative 8. Negative 8 times 2 is negative 16. You just take it one step at a time, guys, right? Plus, and yes, negative 2 squared is positive 4. So what will I have here? Ooh, look, 8 and minus 6 minus 2 is minus 8. All over negative 16 plus 4 is negative 12. But it doesn't really matter because the numerator ends up being 0, and so your answer is 0. Nice. So did you guys, I don't know if you guys got a chance to finish, but did you guys get any of these answers?
Yes,
Alright, you got the 0?
sir. Yeah.
Alright, lovely. Now,
So this is wrong.
yeah. So at the end of the day, no, that's fine. Yeah, I mean, it would be if you had end up getting negative 12 divided by 0. Well, then the answer here is not 0. The answer here is no solution, right? Or you could also say undefined. We do not know the answer to this question, right? So, so the whole point here is I have a function, and if I put something in that bracket, then you just, something in place of x over here, then you just have to take whatever I put. So if I say the f of Kitty, no matter what it is I put in there, I just replace an x with whatever it is in here. So I will have 2 times Kitty squared plus 3 times Kitty. It's hard to draw Kitty. minus 2. Everybody get the point, right? 2 times kitty cubed plus kitty, you're looking like Batman now, squared, right? So whatever it is you put in there, you just put that where x is, and that becomes important now, right? So that becomes important now, right? And you'll see why. So I have composite functions now. So what if I have one function, the f of x is equal to x plus 3. And what if I have a next function, and the next function, we could call that the g of x, right? We're just using f and g to show us two different functions. G is still a function, right? And let's just say that is x minus 2, right? So we saw that if I had the f of 2, I just literally taken 2 and putting it where x is, right? Whatever is in there, right? But what if I have now the f of the g of x? What do you think I have to do? Scotia, any idea? Find for the g of x. Well, look, I find it. Look at D. That is the g of x. What do I have to do now?
Put that into x and
right. So you see how the g of x get put inside f of x? Right? Well, that is exactly what I had to do. Just like how I had the f of 2, and wherever I have x in the f equation, wherever I have x, I'm gonna put 2. Well, in the f equation, wherever I have x, I'm gonna put g of x. So therefore, my God, what is this? Jeez, I wish I could run them down and burn down the car while they're driving in it, right? Anyways, this is being recorded, so I shouldn't say such things, right? If I have the f of the g of x now, right? That is taking the f of x, which is x plus 3. Remember, the f of x is x plus 3, right? But whatever I have x, I'm gonna put the g of x in there. So what is the g of x? X minus 2, right? So I'm gonna take this x and I'm gonna put the g of x here, x minus 2. So now the f of the g of x is equal to x minus 2 plus 3. So therefore the f of the g of x is equal to x minus 2 plus 3 is minus 1. So I end up with x minus 1. Alright, so Shazay, Caitlin, do you understand that what I did was I took one function and I substituted inside of another function? Hello, Shazay, Caitlin. Right? Shazay, you understand what I just did there, right? Right. Caitlin, you understand what I just did there?
Yeah.
All right, nice. Now, something that might confuse you is just another way of writing it, right? Another way of writing it is instead of writing the f and brackets the g of x, some question would just write it like f g of x. Right? And you have to know, I had to take the g of x and put it inside that one, right? So write this down. Let me know when you're done it.
+1?
Ooh. Oh, yes, it would. Thank you. Yes, it would. Thank you. -2 plus 3 is +1. Thank you very much, Kusha. Oh, things will get a little bit interesting here now. What if I add another function, the h of x? Let's say the h of x is 2x plus 1. And what Mr. Man come and tell you is find it have two ways they could write it there. You had to find the f of the g of the h of x. Somebody tell me what to do there now. And of course, they could also write it like this: f, g, h, x. What to do there? Yes. So first, I'm gonna need to put the h in the g and find what that is. And whatever is the answer for that, I'm gonna need to go and put that in the f. So first, I have to find the g h of x, right? I put in the h in the g now. So I put so the g of x is x minus 2, right? And let me just put the brackets here so that you guys could know how to do it, right? The g of x is x minus 2, and I'm gonna put the h of x wherever it have x. So the h of x is 2x plus 1, so it'll be 2x plus 1 minus 2. So x minus 2, that is the g of x minus 2. And of course, I'm putting the h of x in there. So now I'll end up with 2x plus 1 minus 2. And now I will end up with 1 minus 2 is minus 1. 2x minus 1. And this here is the g h of x. And now I have the gh of x. I could put this now into f of x. So therefore, the f of the gh of x, and this is like those Russian nested dolls where you have a small doll inside of a bigger doll, inside of a bigger doll, inside of a bigger doll. You have a function inside of a function, inside of a function, and they can give you how much functions they want, right? So now I found the f of the h of x, and I'm putting it in f. Sorry. Oh gosh, this is good. I found the gh of x, which is this, and now I'm putting it in f. So what is f of x? F of x is x. I'll put in x here, which is 2x minus 1. Remember, wherever I have x, I'm gonna put gh of x, right? So 2x minus 1 plus 3. So that is 2x minus 1 plus 3, and that works out to be the f of the g of the h of x ends up being 2x minus 3 plus 1 is plus 2. So Shazay, do you understand this piece of madness that we do here? What do you mean, yeah? I don't like that. Tell me, what's your thoughts? Right? So when a question asks you the f of the g of the h of the q of the p of the r of x, yeah, what you're doing is you take the r of x and you put it in p. And then whatever you get for that, you take that and you put it in Q. Whatever you get for that, you take that and you put it in H. And the answer for that, you take that, you put it in G. And the answer for that, you take that and you put it in F. So write this down quick and let me know when you're done.
Yeah, so far.
Yeah, nice and easy. And this one here is basically the kind of question you'll get in CSEC. They'll give you two simple linear equations and they'll tell you to find the f of whatever. Right? So the first one I have is the f of the g of x. So f g of x. And let me use a different color so that I could distinguish question from the answers, right? And so we have the f of x, 3x, and wherever I have x, I'll put the g of x. So that's 2x plus 5 minus 1, because we're still in f of x, right? So 3x minus 1, that is the f of x. And so what do we end up getting? 3 2s are 6x, and 5 3s are 15 plus 15 minus 1, which is 6x plus 14. You get that, Skosh?
Yes, sir.
What about Shazay? Shazay, you get that?
Yes, sir.
Alright, and Caitlin, did you get that?
Yeah.
Alright, well Caitlin, you'll be in real good shape then when you reach in Form 5 if you're doing this. And of course now we're flipping it around. Now for number 2 we want the g of the f of x. Right? So I'm gonna take is the g of x, the 2x, and I'm gonna put f of x inside here, 3x minus 1 plus 5. So remember the g of x is 2x plus 5, and I'll put in the f of x inside of it. So now I'll have 2 3s are 6x minus 2 plus 5, and I get 6x plus 3. I hope I didn't make any mistakes there. I hope you all will let me know if I do, right? For number 3, we have the f of the g of negative 3. So the first thing I want to find is the g of negative 3. The g of negative 3 is 2 negative 3 plus 5, which is 2 3s are negative 6 plus 5, which is negative 1. So therefore, the g of negative 3 is negative 1. Hence, the f of the g of negative 3, I'm going to take the negative 1 and put it in f. So that is 3 negative 1 minus 1. Yeah, 3x minus 1, that is f. And that is negative 3 minus 1, which is negative 4. Scotia, Shazay, Caitlin, how you all felt about this one?
Good.
Right, the final answer there, let me write the final answer. Therefore, f of the g of negative 3 is negative 4. Shazay, you got through with this one? Or did you not reach?
Yes, sir.
Alright. Simple stuff. Well, with the way things going, we'll be over early today, so that's nice, right? Because all we have to do is the inverse after and be done, right? And the last one here, the g of the f of negative 3. So first we had to find the f of negative 3. So the f of negative 3 is 3 into negative 3 minus 1. 3 3s are negative 9 minus 1, which is negative 10. That is the f of negative 3 is negative 10. So therefore the g of the f of negative 3 is really the g of negative 10, which is 2 into negative 10 plus 5, which is negative 20 plus 5, which is negative 50. Yes? No?
Yeah.
Yes, sir.
Alright, so this here is the g of the f of negative 3. That's what the question asks you for. Good job. So that was it for composite functions. Actually, you know, you can expect for CSEC that you might get a question like this. Sometimes they might give you 3 functions. It depends on which question it is or who is the person setting the question. But sometimes they might give you 3 functions. So you might get something like the f of the g of the h of 2. You know, you might get something like that. And of course, you know, you have to put the 2 in the h. And then whatever you get for that, you put it in the g. Whatever you get for that, you put it in the f. They wouldn't give you more than 3 functions, right? Now, I have this one here, and this one is just kind of more of the same. So do you all want to do this one now? Listen, just take a screenshot of this one, and this one is for homework, right? This one is just the same kind of question, but this time we have 3 functions. And remember, this is the same as asking for the g of the h of x. Number 2 is the same as asking for the f of the g of x. So they wouldn't give you with the brackets, yeah? I just put the brackets here for you guys to kind of understand what it means. This here is the f of the h of -1. This here is the g of the f of 1. And this here is the g of the h of the f of x itself. Right? So, just take a screenshot. Tell me when you just say shot when you're done.
Shot.
Shot.
Alright, nice. So this is just more of the same really, so I wouldn't waste your time to have you do it in class here, right? So now we're going to get into the cool stuff, which is it's pretty easy. It's nothing tough at all really, right? It's nothing really hard. And now what we're talking about is the inverse of a function. Right? So let's see. We have, let's just say we have f of x is equal to 2x plus 3. And the question says, find the inverse, f inverse x. Right, that's how you just write the inverse of a function. F to the power of 1, and then you -1, and then you put the x. Right? So f inverse x. Now, what we do here is just really simple. Instead of f of x, we're gonna go back to y. So y, so let y equals 2x plus 3. And when we make y 2x plus 3, all we have to do is make x the subject of the formula. Therefore, 2x plus 3 is equal to y. So, you know what? Let me just write make x subject. Right? So make x the subject. So therefore I throw over the 3, so I'll get 2x is equal to y minus 3. And now I throw over the 2, so I'll get x is equal to y minus 3 over 2. So that's all I did was make x the subject. And now here's the hardest part. Here's the part that everybody just get wrong. Now, literally switch y with x. So when I did it, I got x is equal to y minus 3 over 2. Literally just no subject to the formula, no algebra, literally just switch it. So I'll put now y is equal to x minus 3 over 2. And that's it. You're done. Therefore, the f inverse of x is equal to x minus 3 over 2. That's it. Scotia, how does it feel for you?
Good.
Easy, right?
Yeah.
Right? So all you have to do is put the function in terms of y, and then make x the subject to the formula, and then literally just switch the x and the y. Right? And you'll have your f inverse x. So we have this question here. We have two functions, f of x and g of x. Part 1, find the f inverse of x. Part 2, find the g inverse of x. Part 3, find the f inverse of the g inverse of x. And part 4, find the f inverse of the g inverse of 3. 1, 2, 3, 4. 2's are 8 minutes. I'll give you 8 minutes to do this. I've done it, so
I step on 3.
you step on 3. Why?
I don't know what to do.
Well, I mean, think about it. It's the same thing, right? You basically have this g inverse of x that you're going to put inside the f inverse of x, eh?
But can I use the g inverse of x from number 2?
Yes, that is g inverse of x.
Okay.
Yes. So it's pretty simple, right? So you're taking the g inverse of x and you're putting it in the f inverse, the same f inverse from number 1, right? And then for number 4, you're putting 3 inside of g inverse and getting that, and then putting that in f inverse, yeah? So I'll give you guys 2 more minutes. So let's find f inverse of x. That's not right. That's not the correct way. F inverse of x implies let y equals 3x plus 2. Therefore, 3x plus 2 is y. X is going to be y minus 2 all divided by 3. Therefore, f inverse x is equal to, remember, you just switch the x with y. I actually skipped that step there. So you switch the x with y. So now I have y is equal to x minus 2 over 3. So therefore f inverse x is x minus 2 over 3. Yeah? No? Scotia? Hello? Oh, sorry. I did not realize my microphone was off. But you can see what I did here, right? Scotia, you got this?
Yes, sir.
Alright? So you can see here that let y is equal to x, 3x plus 2. And just make x the subject to the formula. You switch your x and your y. And boom, you have it there. Shizzy, you okay with this, right?
Yes.
Nice. So, what do we have next? We have next the g. Oh, I'll want to keep a note of the f of x. So I'll keep a note of it here. The f inverse x is x minus 2 over 3. That's a 2, right? Now I want the g inverse of x. So that tells me, that implies let y equals 2x minus 1. Therefore, 2x minus 1 equals y. X is equal to y plus 1 all divided by 2. switch x and y, therefore y is equal to x plus 1 divided by 2. Therefore, g inverse of x is equal to x plus 1 divided by 2. And I'll take this and I'll put it over here. So, Shazay, you got that one?
Yes, sir.
Nice. So, what do we do now? Well, now we do the third one. Oops. Come on. Which is the f inverse. Inverse of the g inverse of x. So all I'm doing there is I'm taking g inverse of x and putting it inside the f inverse of x. And you see some dread algebra might have to take place here. So let's see how this works out. So what that is that is the f inverse of, and then the g inverse of x is x plus 1 all over 2. Yeah? So I'm taking the x plus 1 all over 2 and I'm putting it in f inverse x. So that is equal to f inverse x is x minus 2 on 3. That's quite a dread piece of algebra there. Okay. So we can remove the brackets there. X plus 1 on 2 minus 2 all over 3. Okay. And you know that we might have to do something with this numerator here. So I'll go in my working column and I'll say, well, x plus 1 over 2 minus 2 over 1. And I'll make one fraction. So we know how to do fractions. You multiply a denominator, 2. 2 times 1 is 2. And then you cross multiply. So x plus 1 times 1, that is x plus 1. Right? And then minus 2 times 2 is 4. Right? So what do I have here? X plus 1 minus 4. 1 minus 4 is what? X minus 3 over 2. So now I'll work out the fraction on top here to get me x minus 3 over 2 over 3. Yeah? And of course you know that when you're dividing, well, actually you don't really need to understand that. Everybody understands what I did so far though? Caitlin, you're okay with this so far in terms of how I got from here to here?
Yeah, I did.
Alright, okay, right. Shazia and Scotia, I hope you're all okay as well. Remember, this is really x minus 3 all over 2 multiplied by a third, eh? Right? If you divide them by 3 and multiply by a third, which means I could multiply my numerators and my denominators. So the answer is x minus 3 all over 2 3s is 6. Right? So therefore, f inverse g inverse of x is equal to x minus 3 over 6. Scotia, you get this one?
Yes, sir.
Alright. Very good. Lovely, right? The f inverse of the g inverse of 3. Now, I already worked out the f inverse of the g inverse of x, right? So recall the f inverse of the g inverse of x is just simply x minus 3 over 6. Therefore, the f inverse of the g inverse of 3, I'm just taking the 3 and putting it in there. So that will be 3 minus 3 over 6, which is 0 over 6, which is 0. Alright, so Shazay, is this a lot easier than you thought it was going to be? Yeah, you always have this problem with overthinking things. So that was it for composite functions, guys, right? So you could see here that composite functions are really cool because you're putting a function inside of a function. So, Scotia, do you know any practical applications for this? All right, here. So, question. Or quest. This is a quest, not a question, right? We have the f of x equals 2x minus 3 all over 3x plus 4. Then we have the g of x equals 4x plus 1 all over 3x plus 2. And then we have the h of x. That is equal to 3x minus 1 all over 2x plus 5. The question is, number 1, find the g of 3 and the h of negative 2. Number 2, show that the f of the h of negative 2 equals 1. Number 3, find the h inverse x. And number 4, and this is the one that you might scratch your head a little bit for, and I'm not going to explain it. I want you to think about it, right? Think about it. State the real number and look at the words when you're thinking about it. Look at the words that they're using. State the real number which cannot be in the domain of g of x. State the real number. A real number is a number. It could be any number, right? Because real numbers is all numbers, right? And which cannot be in the domain. They use that word domain. We learned that word last class. I wonder what that means. State the real number which cannot be in the domain of g of x. Think about it. Let me know when you finish. Write this down.